All right, Cubs. Hi there. We're going to move on to the next part of probability, and this is called using probability to predict. Okay. I'm going to draw my lines, and I'm going to be patient and wait so you can pause. Using probability to predict. And our EQ is, what do you set up to predict probability? Or to predict event, to predict future events, we'll say that, future events. Remember, events and probability does not mean like a birthday party or baseball game. Events and probability are the probability you're looking at, or the thing that's going on that you're trying to study. So it's a kind of bummer, guys. I missed doing the whole like intro lesson thing with you guys, and we just kind of got to cut to the chase. But that's just kind of the way it has to go with this nature. And I'm trying to be really concrete with you guys of what you need to do, because I got that feedback that it's good to just have stuff to do. Okay. So what we can do if I'm going to give you kind of like an explore problem, kind of. Okay. So we know that if rolling a number greater than 4. Let's talk about the probability of rolling a number greater, I don't know why I put the R there, greater than 4. The probability of rolling a number greater than 4, okay? We know that that happens 2 times because a 5 and a 6 are greater than 4, and that happens twice. Clean this up. Okay, so that happens 2 out of 6 times, which reduces to 1/3. So we know that the probability of rolling a 5 or a 6, the number greater than 4, happens 2 out of 6 times, so 1/3. So if I asked you, okay, so technically speaking, or theoretically, if I was to roll a dice 30 times, how many times can I expect to roll a number greater than 4? So let me read that. If we know that the probability of rolling a number greater than 4 happens 2 times out of 6, a 5 and a 6, which reduces to 1/3, and I roll a dice 30 times, how many times can you expect that I roll a number greater than 4? Think about it. If you want to pause and guess on your own, you could go ahead and do that, okay? So I want to think of it this way. If it has to happen 1 out of 3 times, so a number greater than 4 out of the total, right? So the probability of something happening greater than 4 out of a total number of times you roll is 1/3. And if this rolling is a 30, we're looking for the top. Look at, it's just A, equivalent fractions, if you want to call it that way, or B, it's a proportion. So you have 2 ways you can solve this. You could either say, okay, to get from this 3 to this 30, I have to times by 10. So multiply that by 10 to make these things equal. Oh, X is 10 number of times you would expect to roll a number greater than 4, because that 10 is 1/3 of 30. Or you could have done the cross product way, and you could have said, okay, numbers greater than 4 out of the total, that's 1/3 of the time it happens. So how many out of 30? We could do a cross product. 3 times X is 3X. If you don't remember how to do a cross product, 3 times X is 3X. 1 times 30 is 30. To get X by itself, we divide by 3 on both sides. And I get left with 3/3 makes 1X. 30 divided by 3 is X is 10. So either way, if you want to do equivalent fractions or a proportion, you can get it that way. So let's write that down. So our steps. So the first step we need to know is we need to find the probability of it happening, which we learned in our last lesson. Okay. So first we found the probability of a number greater than 4. Then we need to either A, set up in equivalent fraction, or a proportion. I don't care which method you use. You have to use the method that's most comfortable to you. Okay. And when we do both this, we have to make sure that we put we need to put the total on bottom. Okay. So the total times we think we want it to happen. Okay. So make sure your total is on the bottom. Okay. And the probability is on the top. Okay. Let's practice. Okay, let's go ahead and practice this. If I am a volleyball player and I make 8 out of 10 serves typically, so Miss Minch makes on average 8 out of 10 serves. If I'm in a game and I serve, let's say 80 times, no, let's make it a number that's not confusing with those numbers. If I serve 40 times, how many can I predict I will make? Okay, so let me explain that to you again. If I'm a volleyball player and I make 8 out of my 10 serves every time I'm up at the service line, and I'm going to serve 40 times in this next match, how many can I predict that I will make? So again, you can solve this 2 ways, equivalent fractions or proportions. Okay, so I'm going to remember, so this is the serves out of my total. I always like to set up a key. If I make 8 out of 10, that's my probability. So I just did step 1. I have a probability of making 8 out of 10. That's why athletes come up with their batting average and stuff like that, or their free throw percentage, so that people can, that's why they talk about that. That's why they look at probability and percentages for athletes, so they can predict how many they'll make in a game, just so you know. So my question is now asking me, how many can I predict if I serve 40 times in a game? Well, the total goes on the bottom because I have an opportunity to serve 4, and my X represents my unknown. My X represents how many I might make, or how many I can predict I make. Again, 2 ways to do this. I can see that this is just multiplied by 4. It's equivalent fraction, so I multiply 8 by 4 and I get X is 32. Or I do a cross product. 8 over 10 is equal to how many out of 40? I put a cross there, I get 10 x's equal, 8 times 4 is 32, add the 0. I divide both sides by 10 to get x by itself, and I get x equals 32. Both ways get me that I should make 32 of my serves, because 32 is 8/10 of 40. Okay? Some of you might also start to see a third way we could do this. You could take the probability and multiply it up by your total. So some of you might say, okay, if I'm making 8 out of 10, I can multiply that by the number of serves I'm going to get, and that will get me the same number. Think about it. Every whole number has an imaginary 1 below it. 8 times 4 is 32, add the 0. 10 times 1 is 10. Chop off the zeros, 32 over 1 is 32. So you could also multiply the probability of something happening by the number of times you have that opportunity. Okay. We'll do one more practice problem, and that's it for these notes, okay? Okay. Let's say we're going to pretend someone is has a garden. Okay, let's pretend they have a garden. Okay. Someone has a garden, and one year, out of their 12 plants, only 7 survived. So 7 plants out of 12 seeds survived. Okay. So for someone, 7 plants out of their 12 seeds survived. And so they go and they buy a pack of, we'll do a different number. We'll do 72. So they go and buy and plant 72 seeds. Okay. How many can they predict will survive? Predict how many will survive. So 7 plants bloomed out of 12 seeds. And then next year they buy and plant 72 seeds. How many can they predict will survive? So I'm going to do the 2 ways again. So I'm going to say the seeds out of total. Okay. So typically 7 out of the 12 work. So how many out of 72 are going to? It's an equivalent fraction or a proportion. Well, I know that to get from 12 to 72, I am multiplying by 6. So 7 times 6 is 42. So technically 42 of the seeds should seed results. Should get results. Or I can do a cross product. And this is going to be a big number, but good thing I can do my math because I'm smart. Okay. So 7 out of 12 equals X out of 72. I'm going to cross multiply. 12 times X is 12X. 7 times 72, I don't know that by heart. So I'm just going to go over here and do some long multiplication. Line up that last digit. 7 times 2 is 14. Carry the 1. 7 times 7 is 49. Plus 1 is 50. So 504. To get X by itself, I need to divide. And I'm left with X's. I don't know what 504 divided by 12 is. Good thing I know how to divide. $12 does not go into a 5, so I put in a 0 directly above it. 12 goes into 50. How many times? 4, because 4 times 12 is 48. 50 minus 48 is 2. Bring down the leftover 4. 12 goes into 24, exactly 2 times. I have no leftovers and no remainders. Aha, X equals 42. So 42 of the plants should be expected to survive, or seeds should be expected to turn into plants. So, or if you wanted to do that other way, you could take the probability, 7/12. I'm going to use a different color because we're going into a different method. 7 out of 12 times the number of things that are happening, which was 72. Every whole number has an imaginary 1 below it. Right, 7 out of 12 times, we got 72. So now 12 times 1 is 12. 7 times 72, I don't know that by heart, so I'm going to go do it over here. Oh, I do. I have it right here, 504. Oh, and 504 divided by 12 was 42. We already did all that work. So I didn't need to solve it again because we did it that way earlier. So there's 3 different ways I've really taught you. You can use equivalent fractions, you can set up a proportion, and you can take the probability of it happening, that fraction, and multiplying it by the events that are happening. Okay, the number of occurrences, okay? So I don't care what method you use, you just have to make sure whatever goes on top, and your total should probably always go on bottom, okay? Have a great day. You can go ahead and write your summary now for this one. You could have written the one from yesterday too, or I'm not sorry, yesterday, the last video on intro to probability. So make sure you've written your summaries for those. They'll be due eventually. So you learned how to use probability to predict future events. Okay, thank you.